Hi guys, it is Savannah again, and I'll be doing my last advanced concepts for my poster. So we will be talking about nucleotides, ribose, and ATP. So nucleotides we know can be pyrimidines and purines. The big difference in synthesizing these is that pyrimidines, as you can see here, they build off of a ring and then add a ribose later, while purines already have the ribose attached and they're adding onto the ribose. So through this we yield UTP, CTP, TTP, ATP, GTP, which are triphosphates. Nucleoside triphosphates, and then the nucleotides that we use for like genetic material of DNA and RNA, those are nucleoside monophosphates, so it's a very short conversion to that when needed. And then speaking about the ribose, that are precursors for both, the reason we're talking about that is because that is involved, well, not only is the precursors for literally our genetic information, but it also aids in the synthesis of ATP, and that is made from the pentose phosphate pathway, which yields NADH and the ribose 5-phosphate, as well as other 5-carbon sugars. And NADH kind of leads us into what we're going to be going into now. So now I'll talk about ATP. Let's see. Yes, the ribose 5-phosphate that's involved in the preparation of glycolysis. So let's see. And it also is, well, we'll just go into it. So for this discussion, we're starting with glucose. We don't need to prepare glucose, but just it's needed. Preparation is needed. But anyway, so start with glucose, and we lose ATP with the with phosphorylating the glucose and the fructose 6-phosphate. But then we gain an NADH, which in the cytoplasm yields 1.5 ATPs. And so for those two NADHs, we'll yield 3 ATP. And then we further move on to substrate level phosphorylation, which also yields, 2 ATP. And then we finally have our pyruvate right here, which then goes into the pyruvate dehydrogenase complex, where it is oxidative phosphorylation of the pyruvate, which yields more ADH. I just realized I may have been saying ADPH. I don't know. I meant to say ADH. If I was saying ADPH, I apologize. So anyway, yields oh my gosh, now I'm messing myself up, NADH, but this is now in the mitochondria matrix, so it's going to yield 5 ATP because it'll account for 2.5 each one for ATP, and then it can finally enter the Krebs cycle, where, let's see, no ATP is used, and there is substrate level ATP gained, as well as the NADH, which is in the mitochondria matrix, and the FADH, which I believe yields 1.5. And this goes around twice, so the 3 NADH turns to 6, and that's going to be multiplied by 2.5, which yields 15, I believe, if I just did that right in my head. Whatever. I think so. And then the FADH2 yields 3. So that's where we get our 32 ATP for every one glucose molecule. That's pretty crazy. So I covered the nucleotides, ribose, as well as ATP, and I am not joking when I say I'm going to frame this poster. So thank you for listening. Goodbye.